So here we have the 2017 question 6. This is on trigonometry and it's Leaving Cert ordinary level. So we are asked to find the distance x in the diagram below, and this is not to scale. Give your answer correct to 2 decimal places. So when the tools that we have available to us in trigonometry, firstly we have kind of methods that we can use to solve right angled triangles. So right angled triangles. And we have a few tools that we can use in all triangles. So with right angle triangles, we can use Pythagoras' theorem if we're looking to get information on sides. Or we can use our ratios, which are sin, cos, and tan. This is not a right angle triangle because there's not a 90-degree angle, and even if we were to get that angle here, it wouldn't be 90. But with all triangles, so they can be right angled or not right angled, we can use the sine rule and we can use the cosine rule. So the question I would ask, say if I was, should I use the sine rule or the cosine rule? Well, I would ask myself, do I know one side and its opposite angle? If the answer is yes, use the sine rule. If the answer is no, use the cosine rule. So I'm just going to have a look at my triangle. Well, firstly, I can see that I could actually fill in that angle there. So it's going to be 100. So to get that angle, all the angles in a triangle have to add up to 180. So I could do 180 minus 65 minus 63. So 180 minus 65 minus 63, and then I get 52. So I also know this angle here. So do I know at least one side and its opposite angle? Well, I know 10 and its opposite angle here. So yes, I do. So it might be wise to use the sine rule. So the sine rule is in our log tables, and it says, say if we have a triangle with angles A, B, C, and the sides opposite these angles, so the side A is opposite angle A, the side B is opposite angle B, and C is opposite angle C. Well, we can say that the side of A over sine A is equal to the side B over sin of B. So what I sometimes do is, to get the opposite sides, I would draw a line from the angle to the opposite side. So this angle goes with that side, and then the side we want is this side here, and that would go with this one here. So what I would do here, so I'm going to have to do, so my side over the sin, so I'll just draw out another diagram so we can get it all on one page. So 63, 65, 10, x. So we drew a line from here to here, and then our formula is a over sin, so the side over the sine of the angle opposite it over is equal to the other side over the sine of the angle opposite it. So we can write 10 over the sine of the angle opposite it, so 10 over sin 63 is equal to x over the sin of the angle opposite it, which is 52. So now we have to do what I would like to do is get x by itself. So I could multiply both sides by sin of 52. So I could say I'm dividing by sin of 52 on that side. So I'll be multiplying by it when I bring it over to this side here. And then that's over sin of 63. And that will give me x. So the way I plug that into my calculator, so I'll just do it out first. So 10 sin 52 over sin of 63. So I plug it into my calculator like that, and then I get x is equal to 8.844, and it might say correct to 2 decimal places, so it'll be x is equal to 8.84, and that's in centimeters. So that is my length of there. And then in part B of this question, we're given another triangle. So we are given another triangle here, and this is y, this is 8.5 centimeters, this is 53.8 degrees, and this is 10.2. So I'm going to go back to the rules that I kind of written out. So if I have a right angle triangle, I can use Pythagoras, or I can use my ratios sin, cos and tan. This isn't a right angle triangle, so I'm not going to be able to use them. If I have for all triangles, I can use the sine rule and the cosine rule. So the question I would ask myself, do I use the sine rule or the cosine? Do I know one side and its opposite angle? So I'll check. So if the answer is yes, I use the sine rule. So this is a side I know, but I don't know the angle opposite it. This is a side I know. I don't know the angle opposite. So I don't know one side and its opposite angle. So I'm going to use the cosine rule. So the cosine rule is in our log tables. So this is the cosine rule here. So basically, say if we had a triangle A, B, C, and side A is opposite angle A, side B is opposite angle B, and similarly with side C. So we could say A squared is equal to B squared plus C squared minus 2BC cos A. So whatever angle we put here, the side opposite it has to be the side here. So the only angle that we know is going to be this one. So we could actually call this angle A, and then we could call this side A. We could call this angle side B, and we could call this side C. So we could say, this is our formula. So we could say that side A, we could call it y. So instead of A squared, we'll put y squared is equal to B squared, which we let equal to 8.5 squared, plus C squared, which we said was 10.2, minus 2BC, so 2 by 8.5 by C, which is 10.2, and then I'm just running out of space, and then cos A, which is 53.8. So if I'm to do this, so y squared, so I'm going to add 8.5 squared plus 10.2 squared. So if I put them together, I get 176.29, and then that's going to be minus, so 2 by 8.5 by 10.2. So then I get minus 173.4, and then that's going to be cos 53.8. So if I want to get y by itself, I can get the square root of both sides. 176.29 minus 173.4 cos 53.8. So the square root of 176.29, subtract 173.4, and then cos 53.8, and then I get an answer of y is equal to 8.595, and it said correct to 2 decimal places, so y is equal to 8.60. It would round to 2 decimal places. So that is my answer for y.